Hey, algebra students, in this lesson, we are going to be talking about how to divide radical expressions. We're going to find that for some radical expressions, this is really easy. For some, it's going to be a little harder. We're going to learn about two different things in this lesson that we're going to be using throughout the lesson, and then one rule that we're going to follow. The first thing is the quotient property of radicals. And the quotient property of radicals said if we have for instance, the square root of a over b. Now there's an n here because it could be the cube root, it could be the fourth root, the fifth root. It doesn't matter which root. But what you can do is you can break it down so it's like the square root of a over b is the same thing as the square root of a over the square root of b. So all we're doing is splitting the square root between the numerator and the denominator, and that is a perfectly legal move in algebra, okay? Another thing that we're going to be using a little bit later in this lesson is the conjugate of an irrational number. So if we have the number a plus the square root of b, now notice this shows up in letter D, 5 minus the square root of 6. The conjugate of that number is, okay, so it was a plus the square root of b. The conjugate is a and then the opposite sign minus the square root of b. I think you could envision for letter D, the conjugate of 5 minus the square root of 6 is going to be 5 plus the square root of 6. And we're going to be using that in some problems. And now the rule that we have to follow when we're doing problems like this is that you are never, ever allowed to have a square root in your denominator. So our job when we simplify all of these is to make it so that we have no square roots in our denominators. Now, letter A technically has a square root in the denominator because the square root of 5 over 3 is the square root of 5 over the square root of 3. Our job is to eliminate the square root in the denominator. Let's get started. The letter A is actually going to be written like this. The square root of 5 over the square root of 3. Now, what am I going to do about this square root in the denominator? I can't have a square root of 3 in the denominator. Well, I can multiply this by a number that equals 1, okay? I can multiply this by the same thing on the top and the bottom. What if I multiply the square root of 3 divided by the square root of 3? So I have the square root of 3 on the top of a fraction and on the bottom of a fraction. Okay, let's see what happens on the top. Now, we know that when we multiply square roots, that this is just going to equal the square root of 5 times the square root of 3 is the square root of 15, no? And I can't break that down any further from the square root of 15 because the factors of 15 are 3 and 5, and there's no perfect squares in there. Hey, what goes in the denominator? The square root of 3 times itself. The square root of 3 times the square root of 3 is just 3. I got rid of my square root in the denominator by multiplying the denominator by itself. That is the key to most of these problems. So let's take a look at B. What's in the denominator? Because in B, it's the square root of 11 over the square root of x. When I use that quotient property of radicals, it's going to be divided by the square root of x. What am I going to multiply this by so that I can get rid of my square root in the denominator? I have to multiply this by the square root of x over the square root of x. Remember, I have to multiply the same thing on the top and the bottom. That's my only legal move here. The square root of x over the square root of x. So on top, once I do this, I'm going to have the square root of 11x. Can't break that down any further. And the square root symbol, I know it's hard because I can't put the square root symbol line over the top, but it's over everything. So it's a square root of, and under the radical is 11x, okay? Maybe I should put this in parentheses to emphasize that that's all under the radical. In the denominator, what do we have? Well, the square root of x times the square root of x is just x. Can't simplify this anymore because on top, this is the square root of x. It's not x itself. Same with this up here. This is the square root of 15. I can't divide this 3 into this 15 when it's under a radical like that. So this is my answer for letter B. Let's make sure I'm answering these correctly. So letter A, square root of 15 over 3. Letter B, square root of 11x over x. All right, let's move on to letter C. Letter C is the same sort of thing. I have the square root of 6x to the sixth. Okay, now I'm going to notice something right away. Anytime I have a power that's even, I could actually take the square root of that. The square root is just going to cut that power in half. So, I wonder if I could do something about that x to the sixth in the numerator first. I'm going to have to keep that in mind. In the denominator, I have the square root of 27x. And notice that 27x is all under the square root sign. It's not the square root of 27 times x. It's the square root of 27x. All right, so what am I going to do with this one? Well, here's the first thing I'm going to do. I'm going to break this apart a little bit, and we're going to change this to the square root of 6 times the square root of x to the sixth. Can I evaluate either of these square roots? There's nothing I can do with the square root of 6, but I can change the square root of x to the sixth to x to the third. So this is actually x to the third times the square root of 6. I can evaluate that part of the square root right away. I can do the same sort of thing on the bottom. I notice I have the square root of 27x, but that's just the square root of, let's see, let me grab my square root symbol again. That's just the square root of 9 times the square root of 3 times the square root of x. I'm going to leave the square root of 3 and x times each other here. So do you see that this is the square root of 9 times the square root of 3x? If I multiply that back together, I get the square root of 27x. Can I evaluate either of these square roots? Well, I sure can. The square root of 9 is just 3. All right, now, how do I finish this one off? I still have a square root of my denominator. That's not allowed. So here's what I'm going to do. I'm going to multiply by whatever that denominator square root is. This is the square root of 3x and the denominator. I got to get rid of that out of the denominator. So I'm going to multiply this by the square root of, let's do this. The square root of 3x over, and let me just make sure that's in parentheses there to emphasize that that's the square root of 3x over the square root of 3x, okay? Now, what's that going to change into? So on the top, I'm going to have x cubed times the square root of 6 times the square root of 3x. That becomes on the top x to the third times the square root of 18x. I'm going to multiply together everything that's under the square root symbols. Well, wait a second. The square root of 18x is the same as the square root of 9. Okay, the square root of 9 times the square root of 2x. Does that make sense? And can I evaluate either the square root of 9 or the square root of 2x? Square root of 2x has nothing I can evaluate, but the square root of 9 becomes 3 without a radical. And I'm just going to take that 3 and put it out front. Okay, so notice what I'm doing is I'm looking under my radicals and evaluating anything that I can. So on the top here, I have 3x cubed times the square root of 2x. In the denominator, when I multiply these together, I have 3 times the square root of 3x times the square root of 3x. That's going to give me 3 times 3x. The square root of 3x times the square root of 3x is just 3x. Well, that becomes 9x. But wait a second. Before I do that, I'm just going to look. This 3 can cancel a 3 in the numerator that's multiplying everything. So these two 3's are going to cancel. And then this x is going to cancel one of these x's in my, because this is x times x times x, right? That's going to become x squared, and one of these, this x on the bottom is going to cancel. So I'm left with x squared times the square root of 2x divided by 3. Now, that was a lot of steps. Let's see if we got that one right. X squared times the square root of 2x over 3. And remember, that seemed complicated, but really all I did was I kept evaluating square roots that were perfect squares that I could easily factor out one of those perfect square roots and then evaluate it. Let's take a look at letter D. In letter D, we are going to have to do something really fancy to get rid of the square root in the denominator. That's not just a normal square root in the denominator like we've been dealing with so far, because that one has a minus sign in it. What am I going to do with one that has a minus sign in it like this? Well, what I can do, okay, so let's just take a look at what we're going to do here. We'll make this a 3 over, and then I'm going to put 5 minus the square root. Let me just grab that square root symbol of 6. Okay, so this is what I'm dealing with. 3 over 5 minus the square root of 6. Now I need to multiply this by something that's going to get rid of my square root of 6 in the denominator. Here's the trick. We need to multiply this by the conjugate of the denominator. So instead of 5 minus the square root of 6, I actually need to multiply this by 5 plus the square root of 6. And I can't just multiply the denominator. I have to multiply the numerator too by 5 plus the square root of 6. Does that make sense? If I multiply the denominator by something, I have to multiply the numerator. Okay, now let's consider. I'm going to put these in parentheses on the bottom just so we can see exactly what it is that we're dealing with here. Okay, now you'll notice that on the bottom, I have two things that are being multiplied, but they have a plus and a minus in them. How do I combine? Because I'm going to multiply these fractions straight across the top. So it's going to be, and I'm just going to put this in parentheses too, just to emphasize it. That's together. All right, so the top of this is really easy to combine. Let's combine the top of this first. All I'm going to do is distribute the 3 to the 5 and the square root of 6. The top is going to become 15 plus 3 square root of 6. What about the denominator? To combine the denominator, I have to FOIL. It's going to be 5 times 5. Well, 5 times 5 is 25. That's first. Plus outer, 5 times the square root of 6. So we're going to do 5 square root of 6. Minus, because it's going to be plus the inner. Well, the inner is negative 6 times 5. So it's going to be minus 5 square root of 6. That's why we did the conjugate, by the way, because notice what happens to 5 square root of 6. It's plus 5 square root of 6 minus 5 square root of 6. So I'm adding and subtracting the exact same amount. That means that's going to cancel. And then my last term is going to be negative square root of 6 times the square root of 6, which is going to be minus 6. Negative square root of 6 times the square root of 6 is just minus 6. Wait, I can evaluate that. 25 minus 6 is 19. And by using the conjugate, you are always going to cancel the square root out of your base. So this becomes 15 plus 3 square root of 6 over 19. There we go. Lastly, let's do letter E together. Letter E, same thing. We got to use the conjugate of the bottom, okay? But I only have a 3 on top, so that's going to be nice. On the bottom, I have the square root of 7 minus 1. Okay, so this is my fraction that I'm dealing with. What I'm going to do with this is I'm going to multiply this times square root of 7 plus 1 on the top and square root of 7 plus 1 on the bottom. How did I get that number? That number is the conjugate. And I know that when I use that number, I'm going to cancel out my square root on the bottom. That's the only way to do it. All right, so on the top, what am I going to have? 3. So this is going to equal 3 times the square root of 7 plus 3. In my denominator, I'm going to have, let's see, first, inner, outer, last. So the square root of 7 times the square root of 7 is 7. Let's see, outer, square root of 7 times 1 is, so it's going to be plus the square root of 7. Inner, minus the square root of 7. Oh, look at that. Plus the square root of 7 minus the square root of 7. That means that square root of 7 term is going to cancel. And then minus 1. 7 minus 1 is 6. And it looks like I'm done on this one. But wait a second. Let's just look at this numerator again. Can I factor a 3 out of both of these terms? I sure can. It becomes 3 times 7 plus 1. Okay, I factored a 3 out. Does 3 cancel with 6? It sure does. The 3 becomes a 1, and the 6 on the bottom becomes a 2. And that is how I solve that kind of problem. Square root of 7 plus 1 over 2.